Good afternoon, everybody. My name is Alberto Cerri. I'm working at ÖBU, Verband für nachhaltiges Wirtschaften in Zurich, as a project manager, circular economy. And today I will lead you through our webinar, Fit for Reuse, the case of steel beams. I'll show you our short presentation. Let me first tell you a few about the organization of the next hour. You know that we are recording this webinar and we are planning to put it on YouTube so that it will be open to see for everybody that is interested. We are planning to finish in 1 hour, but maybe we will have a lot of questions from you and then we will stay a little bit longer. We are very much interested in your feedbacks. If you have special topics or questions, please let us know, and you have to understand what you are getting today is work in progress. We are not finished with this work, and there is more activities that we are planning, and we are very much interested in your feedbacks. To collect your questions, we have this Slido page. You will get now in the chat the link and the code. You can announce yourself there and type your questions. We will answer them all at the end of the sessions, and it is thought as an open-end session. We will take the time to answer all your questions. Today table, short introduction. I'm almost finished with it. Then Veronica from Eberhard will present the general idea of the CBI booster. Daniel will dive into technical details of the non-destructive testing. And Veronica will show us what are the consequences for everyday practical work. And as I said, then we will have enough time for all kinds of questions. Veronica works at Eberhard Bau. She is project leader and she is in charge of the reuse skill. Daniel Galsterer is head of materials technology at Swiss Safety Center. And as I told you myself, I am project manager circular economy at ÖBU. One short idea or information about what we are doing at ÖBU with the RUSS project. We are really trying to organize a circular supply chain for reused steel in Switzerland. We have been working on this project since August 21. We were able to bring at the table, I think, all the relevant stakeholders and create a kind of alliance for reused steel. From the alliance member, we learned a lot about obstacles and chances of this circular supply chain. Some obstacles that we could see are, for example, missing time, missing information on the parts that are to be reused, missing standards and missing digital tools for the exchange of information, quality issues, surface corrosion and surface contamination, stock capacity, and last but not least, business models. We are addressing all these topics with the help of our alliance members. Today, Veronica and Daniel will tell you about one of these difficulties or one of these issues, the quality. And I'm very happy to give on to Veronica. The stage is yours, Veronica.
Thank you, Alberto. I will share my screen. Do you see my screen?
Yes.
So, hi everyone, my name is Veronica and I work for the demolition company Eberhard. And more or less a year ago, the topic of reuse started really gaining importance in the conversation inside the company. And we decided to start with steel beams of all building components. And this has some reasons. What are the potential of steel beams to become the entry point for reuse? First of all, steel beams are highly standardized and they're not produced in too many different types, let's say compared to windows where you have really a huge selection. They're standardized and available in the same profiles. Then steel beams have sort of high recovery potential because they don't damage as quickly during demolition. The CO2 savings are really high. Through reuse, you can save between 1 and 3 tons of CO2 per ton of recovered material, which is a lot. And then steel, as all other metals, is usually an item which has a very high value. So the potentials are there, but nonetheless, we face some challenges. The first one being efficient demolition, the quality assurance. How do you do inventory of items which you recover from the demolition site? And strategies for long-term storage. So 1 year ago at Eberhard, we didn't really have an answer for all of these, and we decided to focus as a first step on the quality insurance. And this is also the topic that we proposed for a CBI booster, which we won in April, with the goal I mean, obviously there are already ways to test the quality of steel, but the point is to find a way which is economic and which is applicable to the reuse situation. So we applied for this and we got the funding. And what we did next, by the way, we is a team of Eberhard, ÖBU, the Swiss Safety Center, EMPA, and as a late joiner, Gruna. What we did is we selected 60 beams, which are in the storage of Eberhard. And we tested them in 2 different ways. We tested them in a non-destructive way and in a classic way, the destructive way. And then we compared the results. And for more information about the results, I would like to hand over to Daniel.
Okay, thank you very much, Veronica. So, do you see my screen?
Yes.
Okay, perfect. So, I'm very pleased to present the results of the CBI Booster project, Fit for Reuse. First of all, I would like to briefly present the Swiss Association for Technical Inspection, short SVTI, our parent company, and the Swiss Safety Center, where the Department for Materials Technology is located. Afterwards, some words about our tasks, challenges, and how the procedure looks like. And I would like to show you what kind of analysis we have carried out and what results we have achieved. And of course, due to the fact that it was a relatively short project, the further steps. The Association for Technical Inspection has been one of the leading Swiss institutes in the field of technical safety supervision for more than 150 years. The SVTI supports the prevention of accidents, faults, and damages, as well as the safe operation of technical systems, for example, nuclear power plants, pressure vessels, pipelines, and so on behalf of the state, the cantons, and private clients. The Swiss Safety Center, as part of the SVTI, offers specific services, products, and qualifications in the field of security and quality. We have more than 150 employees, more than 10,000 customers, more than 2,000 certifications per year. We have 4 different locations. Our main quarter is in Wallisellen, here in Zurich, and we have an approximately annual turnover of 30 million Swiss francs and giving 300 and more courses per year. So what exactly is the Swiss Safety Center doing? My group, here on the left side, you can see it. My group is part of the Materials Technology Department. We are an accredited testing lab and offering services in the field of materials analysis, scanning electron microscopy, EDX, OES, XRF, in general, determination of the chemical composition of mainly metallic materials, metallography, the study of the physical structure of the metals. We prepare samples by grinding, polishing, and etching, and analyze them using optical or electron microscopy. We carry out some corrosion tests according to different standards like intergranular corrosion, stress corrosion, cracking, pitting, and so on. With the non-destructive testing, we can test components for pores, cracks, etc., using a wide range of variable methods, PT, MT, UT, and so on. And in the field of destructive testing, we carry out some tensile tests and compression tests, Charpy bending, hardness, and so on to determine the material's properties. And last but not least, we also do failure analysis for customers out of different markets, for example, transportation, medical, air, and space. Simply spoken, if they want to know why their components are broken. Furthermore, we have the department Industry Services. Here they are concerned with fire protection inspections, a notified body for pressure equipment, welding technology, and so on. The certification department, we certify mainly management systems according to, for example, 9001, 14001, and so on. Also personnel, but also, as you can see here, some products. Here, this would be interesting, steel and construction according to EN 1090 1-5. Our expertise services is concerned with fire protection, safety audits, environmental safety, and so on. And we also have an academy doing some courses and conferences. So coming to our CBI booster project, Fit for Reuse. For reason of sustainability and resource efficiency, the aim is to directly reuse steel components. As you know, there are some challenges. There are currently only drafts or standards concerning reuse of steel components available. For example, the EN 1090, which generally regulates the design and scope of the testing. But we will see how this can be then applied. In contrast to new steel components, such as hot rolled beams, there is usually little or no information available about these components in their installed state, particularly regarding the steel grade and the steel quality group. In addition, not only the names of the structural steels have changed repeatedly in the past, but also the manufacturing process and the requirements placed on them with regard to brittle fracture and weldability. Until recently, for example, untempered steel cast was often used, which may no longer be used in the construction industry today. So how do we proceed? First of all, we want to test the materials, then we do a classification. For example, it will be a S235J0 steel, and afterwards we certify them. Basically, our research methods can be divided into two categories here, and a non-destructive testing part and a destructive testing. As the name suggests, the destructive method is generally to be avoided. We want to reuse the steel structures. However, some parameters can only be determined destructively. Non-destructive testing methods we use are, for example, visual testing, determine surface conditions like corrosion, deformation, inhomogeneities. Is there a coating, yes or no? And maybe we can say something about the thickness of the coating. Geometrical specialties like head plates, ribs, holes, measurements we can carry out, profile geometry and assignment to standard profiles. We measure the profile height, flange width, wall thickness, length, and everything as far as accessible. The optical emission spectroscopy and the hardness tests aren't NDT methods in the common sense. The surface must be ground and the OES leaves a burn mark, which also must be ground away afterwards. However, the removal is so small that they are listed here in the NDT methods. With the OES, we can make a statement about the chemical composition of the material. We use the hardness measurement to obtain non-destructive indication of the material strength. Actually, the hardness and the strength are fundamentally different, but you can say that they are positively correlated in a way. And as you can see in the picture on the right side, very few steel beams are easily accessible. In this case, we at least reach them with a lifting platform. And if you want to classify the steel, the material strength is very important. And with the tensile test, you get the tensile strength, the yield strength, and the elongation. And with, for example, a notch bar impact bending test, you get the impact strength. In the CPI booster project, the Swiss Safety Center prepared the samples, and they were tested afterwards at the EMPA. However, testing would also be possible at the Swiss Safety Center. And as you can see in the picture on the right bottom side, it would also be possible to take the sample on site from the installed steel beam. So we have recorded quite some data. I will guide you through this table. We classified the structural steel based on their yield strengths, tensile strengths, and elongation according to EN 125. This column on the right side with the different colors. For example, the light green color is an S235, the blue one an S355, and so on. And then we tried to divide them into non-half, fully, and fully killed steels according to their chemical composition on the left-hand side. With these elements, we could analyze on-site, yes. For example, fully killed or killed steels have at least 0.2% of silicon and more than 0.5% of manganese, and or more than 0.02% of aluminium. Non-killed steels are critical as they have distinct segregation zones. Bessemer and Thomas steels manufacturing methods are also not suitable because for the reuse, as these steels generally have a high nitrogen content and due to the air refining, and can therefore age due to nitrite deposition. And based on the chemical compositions and the results of the eddy current measurements, we verify the mentioned nitrate depositions and hence the age-related embrittlement. Can be said that the steel structures here were not manufactured using Thomas process. Usually the best way to detect brittleness, of course, in our case to verify the eddy current measurements is by means of a notch bar impact test. However, the notch bar impact test here, we unfortunately carried out at temperatures of about -20 degrees Celsius, which meant that some of them did not reach the required 27 joule. And temperatures of about 0 degree, it most likely looks different. And at this temperature, we could verify our eddy current measurements. So that is still pending here. However, the aim is not to test every steel sample by means of destructive tensile tests. That would be too time-consuming and too expensive. We would like to use non-destructive testing methods that can be applied on-site. So we recorded the hardness of the steel beams and tried to convert it into a tensile strength using the current standard, the ISO 18265. And we have carried out this using two different hardness testing methods in the laboratory and on-site. In the diagram, you can see the tensile strength over the sample number. The red line is the real tensile strength out of the tensile test. The blue line is the result of the Vickers measurement in the EMPA laboratory, converted to a tensile strength. Most values are slightly overrated. And the green line is the result of the Leib measurement on site, also converted to tensile strength. These measurements are slightly underrated, as you can see. And this is exactly the reason why you have to be careful converting hardness to tensile strength. Also in the standard, it's written hardness testing is considerably different from that in tensile testing. It is not possible to derive a reliable functional relationship. Nevertheless, hardness values and tensile values are positively correlated. So it could be possible. So it should be possible to get a good approximation. We tried different hardness testing methods, also at different positions on the steel beams, web and flange. Afterwards, we converted the results and tried to classify them. In the diagram, you can see the results so far. Every color stands for a steel classification here also. A very colorful slide. We have the 235 in light green, the S355 in light blue. And the last column are the real classifications out of the tensile tests. And the first thing you can notice is that they vary a lot. From 20 overrated samples via the UCI, the ultrasonic contact impedance method, to 1 overrated via LEB measurement. There are various possible reasons for this. Of course, we have the prior mentioned conversation issue, but there could also be local differences of hardness due to manufacturing process, deformation, temperature influence, and so on. The problem with the over and underestimating of the tensile strengths can be seen quite clearly in these two diagrams. You can see the real strengths out of the tensile test versus the derived one from the hardness tests. On the left side, according to LEB, and on the right side, according to Vickers in the lab. You would have a perfect one-to-one relation if the dots in every diagram would be all on the blue line. On the left, you can see quite an under-evaluation with a large spread of the results. And on the right side, you can see an over-evaluation with a lower spread with the Vickers method. The aim would be to exclude over-evaluation as far as possible and to keep the spread of the results as low as possible. We also measured a different position on the steel beams. Interestingly, in the first measurements, we could hardly detect any difference between the hardness of the web and the flange of the steel beams. So it was a little bit surprising for us, but this also has to be verified. So coming to an end, I now would like to briefly summarize the results of the CBI Booster project and mention further challenges. The visual testing is more or less an inventory and therefore not a big challenge, except the accessibility is not given. The chemical analysis is important to define or get a hint about the manufacturing process. Is it kiln steel, for example? Is it manufactured according to Thomas process? This will give you a first hint about the accessibility to age-related embrittlement, as I told. To the NDT methods, there is a good approximation to the mechanical properties via hardness measurements possible, but for a more precise approximation, further tests has to be carried out. We also have to try other measuring or conversation methods in future. Concerning measurement position, at first sight, there is no difference, but this also has to be verified. Age embrittlement is detectable by the current measurements, and I must emphasize we can only detect the age embrittlement with this method and not other embrittlement mechanism. And of course, the true mechanical properties of the steel beams can only be measured destructively. Non-destructive is a good approximation and should stay on the conservative side. The aim would be to just carry out randomly destructive tests, mainly to economic reason. Further challenges will be the question how many components need to be tested at all. Can we group them in a way? Maybe depending on what kind of documents or certificates are available. Maybe according to geometry or the intended use. Which measurements are sufficient? Just the NDT ones? Do we have to carry out the destructive testing maybe? And the goal would be to create a certificate that the intended reuse of the steel component is certified. So thank you very much. And if you have questions, I think we have time afterwards. And I will give it back to Veronica.
Thank you, Daniel. So this was a lot of information. I will try to summarize and what this actually means for reuse now. So first of all, the thing that we found out is that with the non-destructive tests, it's possible to test between 10 and 30 beams per day. And these beams can either be in a storage or they can be in a built structure. It just depends on their accessibility. And then even though the results of the tests are not 100% accurate, they are already giving quite precise results. And this opens the door for possibly having a certificate for the beams. This is a draft of what the certificate can look like. And in a near future, it will be possible to have certified beams for the projects. So this was a very interesting 6 months research project that we did, which sparked several questions. The first one being, obviously, the quality measurement is not the only thing for the steel beams. Another important point is their surface situation and the corrosion. And for this, we have a follow-up CBI booster project, which is ongoing right now. And Alberto is going to tell you more about it. Another question that came up is how do you efficiently create a 3D model or have all of the necessary 3D information of the beam if this beam has to go into a design program or if this beam has to be used for a further design. And as a follow-up of that, beams that are slightly damaged, that are perhaps not perfectly straight, they are partially bent or they have some indentations. These beams don't have to be thrown away entirely. They can still be used under specific conditions. And this is a very important question that we will actually analyze in an upcoming master thesis at ETH. Another important question is how do you bundle the beams in the measurements with the aim of not having to test each single one? This has already been mentioned by Daniel in his presentation. And then, of course, we're putting all of these information together, but nothing is going to become reality if we don't have in the future projects. So Eberhard is looking for partners for realizing reuse projects. With this, I'm at the end of my presentation. I would like to invite you on the 16th of May to the safety talk, where together with the Swiss Safety Center, with ÖBU, and with the TU from Munich, we will dive deeper in this work, and we will have more time to reiterate the tests and hopefully have more insight by then. And I'm going to hand over to Alberto now. Alberto, you're on mute.
You're muted.
Thank you, Daniel, and thank you, Veronica, for your presentations. Before going on with the next information, I would like to say a big thank you to Sylvain Michel from EMPA. He worked on this project too, and he gave us very valuable inputs. Thank you very much for your contribution. What are we planning to do at, let's say, the general level of the project, the RUSS project at ÖBU? We want, of course, to continue following and making the project go forward, as Veronica already said. We see that the implementation of professional platform for the exchange of information for reuse building components is very important, and we will try to help the community to advance on this topic too. And since this idea of developing circular supply chains for reuse components seems to function despite the difficulties and the problems that we still have. We would like to start thinking about reusing cut concrete blocks and trying again to start discussing with industry, with possible stakeholder, how could we organize such an activity, starting again with practical small or middle-sized project. Because I think that in the projects we see the problems and then we can try to tackle them. On the short term, as Daniel already said, we have to complete the measurements on the steel beams to have very good results. And as Veronica said, we are working already on the topic of refurbishing the surface of reused steel. Most of you know that some of the beams have coatings which contains lead or zinc or PCB, and these are sometimes problematic, and we need to have an efficient way to take away these coatings. The project we just started in September, but we are doing progress. We will have a demonstration project together with Immobilien Basel and Circular, and we will inform as soon as possible how this will be possible in an economic way. In addition, we want to increase the networking in this group of specialists. So we are planning round tables next year, maybe in January or February, and this should be group exchange group, networking group of experts like you that can bring your ideas, the difficulties that you still see, and we can try to exchange on this level. One possible topic will be data exchange together with Geoscience, which is a leading supplier of digitalization solution for the industry. We also are created a group, a LinkedIn group, where we can exchange more information on a very informal way. I invite you all to apply to the reuse group in the Swiss construction section that we just published on LinkedIn. ÖBU is organizing many events. The next one you can see here. Impulse radical collaboration. Try to increase the collaboration between companies that really want to go forward in the sustainability. And we have a second event together with InnoSwiss, where you can learn how to implement research project in collaboration with academic partners and with the support of InnoSwiss. As I said at the beginning, we are really interested in your feedback. Here we prepared a form. The link should come now in the chat. Please give us the feedbacks. They are extremely important for us to go in the right direction. And with that, we are at the end of the presentation. We can start with the questions. And for that, we should have here. We have a few questions. The first one is a certificate cover only one beam or a group of beams? If so, how to group them? Maybe Veronica, you want to say something?
Yeah, since we didn't certify beams yet, we don't have an answer. I mean, I see both things as having advantages and disadvantages. Yeah, possibly we can have one certificate for a group of beams and then just have a table listing each beam and the necessary information.
Maybe it can complete. Please, Daniel.
To certify just a single beam would be really expensive. Then the cost of the testing methods would be enormous. So the goal is really, as I said in my presentation, to group the steel beams in a similar way. So, and then we make some kind of testing for one group. Maybe for one group we carry out one destructive test, and then with the hardness measurement, for example, we can confirm that they correlate to each other. So that would be the goal.
Thank you very much. We have a second question. Could you explain what age embrittlement is, Daniel?
Yes. Old steels have a really high content of nitrogen due to the manufacturing process, due to air refining, for example. And this nitrogen can deposit as nitrites on the grain boundaries over the time. And this results in an embrittlement or in a brittle behavior, for example. Normally, steel is very ductile in the fracture process, and the embrittlement is really critical. So it's a problem with the old steels. Yes.
Good, and I hope this is clear enough. Another question is, are other European countries researching this topic, and is there a connection with them? Maybe I can answer. Yes, there are strong activities in the UK, for example. Eberhard, and we had already some exchanges with the group in the UK, which are trying to reuse steel too. And there are some activities in Germany too. We have at this moment only very loose contacts, but if you are interested to know more, I can give you the relevant information, and that I will put it anyway on the LinkedIn group that we are creating now. Then yes, we will share the presentations. How long does it take to test and certify metal beams? Daniel.
Yeah, this really depends on the accessibility of the steel beams. If they are laying in front of you, we are really fast. And if they are high above you and you have to climb there, for example, then it takes quite a long time. So it's around 8 steel beams to 30 steel beams per day.
Per day. So, but if you get an order
in
1 week, you can do it.
8 to 30, I would say.
But how long does it take later to have the results as well? I mean, it's not only the measurement, but also the analysis of the results, right?
Yes, you can have it normally at the next day.
So very fast.
Yeah, we collect the results on site, and then it depends on if we have to do a lot of destructive tests. It takes a little bit longer. Yes, but normally we can finish it within a few days, I would say. Yes.
Then somebody asked if we try to assess the ecological benefit of steel beam recycling using LCA or circular metrics. I can say that we are not working on recycling, we are working on reuse, which is different. There are a lot of studies about the benefit of recycling. Recycling of steel means you melt it and make a new part. And reuse is you don't melt it, but as the word said, you reuse it, which will save a lot more of CO2, as Veronica said before. Then I have another question. Will be the video recording be uploaded online? Yes, on YouTube. When will further research with the steel trade and steel trade constructors begin? This question I don't really understand so well. We are going on, we don't stop. I don't know if the steel trade companies are interested, and we have open doors, as Veronica said, for steel constructors. They should contact us, and then will be a very applied research. And then there is another interesting question: is a certificate always necessary? Does dismantling location and background to the steel beam are known? Why and who needs the certificate? Maybe, Veronica, you can tell about your experience that you made up to now in discussion with possible customers.
So we made the experience that the quality certificate is not always requested. It highly depends on the client. And regarding what information you can have at the point of recovery, sometimes you don't have any information at all. And I'm going to turn the question to Alberto, actually, because I know that you have been involved in a project recently where you measured the quality in an existing building. And if I'm not mistaken, like even some information were not matching to the information found in the plans. Like even though the plans said that some steel should have been identical, then the measurements showed that probably last minute a couple of beams had been sourced elsewhere. Is that correct, Alberto?
Yes, there are a lot of differences between what is sometimes what is in the old paper and what is in reality. So I think that if we can give a certificate, everybody will be sure to be on the right side, and that there will not be any kind of problems. Yes, I don't see any other questions. I think we can close here. If somebody would have any question, you could still write them now in the chat. Don't have anything more, so I think I can close. I thank you very much to everybody for your patience and for being today with us. And please follow us because we are not giving up. Goodbye, everybody.
Thank you and goodbye.
Thank you. Goodbye.
Thank you. Goodbye.
Thank you. Goodbye.
Thank you.
Bye.
Bye.
Thank you. Bye.